Hi guys, welcome back to In Case of Econ Struggles. Welcome to another Sunday Stata tip. Today we're going to be talking about heteroskedasticity and robust standard errors in a Stata regression. So what I've done is I've pulled in the auto data and I've just done a very simple regression of price on miles per gallon. And we've talked about the output from this regression in a previous Sunday Stata tip video, so I'm not going to spend too much time on that. What I am going to spend time talking about is heteroskedasticity. So heteroskedasticity says that maybe this miles per gallon, our explanatory variable, is correlated with the error term. Remember, the error term is the part of price that is not predicted by a regression. We're saying that price is equal to some constant plus miles per gallon plus an error term. And one of the assumptions in that regression is that miles per gallon is not correlated with that error term, where the error term contains everything else that is not miles per gallon. So how are we going to fix this and how are we going to check if it exists? Well, I can check if I do have heteroskedasticity by this simple Stata command called het test. So let's run that. And the null hypothesis of the het test is that I don't have heteroskedasticity. So I can see here that I have a significant p-value, which tells me I probably should be worried about heteroskedasticity and trying to correct for it. How am I going to correct for it? Well, I'm going to run that same regression, but I'm going to add this robust standard errors in there. And that robust standard error is going to change the standard errors and account for that heteroskedasticity. So let's go ahead and run that. The first thing you're going to notice is that when you run this, your coefficients don't actually change. And that is because our OLS coefficients are blue. They are the best linear unbiased estimator, and robust standard errors are not going to change that. Robust standard errors instead are going to talk about the standard error. So if you look here, we've got 53 and 1170, and now we've got 57 and 1376. Which makes sense because if we have heteroskedasticity, our standard errors probably should be a little higher than they were originally. It didn't change anything about our statistical significance, but now we are indeed controlling for heteroskedasticity, and we've talked about how that might be a problem here. So hopefully this gives you a little more information on heteroskedasticity and how to account for it in your Stata regressions. If it did, make sure to like and subscribe, and we will see you next week for another Sunday Stata tip here on In Case of Econ Struggles.